Hello everyone, welcome back to my channel. Today we are going to solve another interesting problem from matrix, set matrix zeros. Prior to this, I already solved problem from the linked list and array. In this entire series, I'm going to cover a different topics problem. Mainly you can see I have already listed down here two pointer problem, sliding window problem, interval problem, string, trees, stack, queues, heap, backtracking, trio, graphs, 1D graph, 2D graph, advanced graphs, and bit manipulation also, considering the dynamic program and the critical problem. So in this 169 problem, you're gonna cover everything. If you try to solve each problem, everything, each problem by yourself, and if you are able to try it by yourself, then I don't think so any problem will be challenging for you. Just think about how you can approach the problem, how you can find a solution of that. Once you are able to find a brute force approach, doesn't matter if we just want to find the solution in first go. Once we find, there are different ways to optimize it, but the first important ask is to find a solution of that. Now, without a further ado, let's get jump in and try to solve the set matrix zero problem. So here we have given a problem statement that we have matrix m by n, and it's integer matrix. If element is zero, right? For example, the column, particular column, like second column, zero row is containing zero. So entire row and entire column, right, would be zero. Similar go with if particular, for example, on the third side, third row here, yeah, so for example this is zero, right, means for example first second column, zeroth index, zeroth column. If it is zero, then entire entire third column, right, and entire first column, zero column should be zero. So simply you can say, right, if it is found zero, you can set everything to the every row from the right side to zero. And if you find that element as zero, the column which is consider highlighting that element should be zero. So you can see it over here. For example, zero is highlighting here this particular row, right? I'm trying to highlight this one, right? So for example, if you can see zero, so everything, right, whichever containing it is, it should get zero, because you can see it is it over here, it over here, right? So these are the two things which we need to consider. Now let's try to understand, how we can think actually to solve a problem. Okay, so here you can see the problem is like, just a minute. Yeah, okay, so you can see, yeah, for example, this is the my input, right? You can see, right? For example, this 1 1 1, right? Yeah, just a minute. Okay, so this 1 1 1, for example, if we find zero here, right, whatever the column it is containing, right? So this is the column which is containing, and this is the row where it is containing. So all the rows where we found the zero. So for example, all the rows it it converted as a zero, and the column treat it as a zero. So first column is zero, so all the column, right, and everything got zero, right? On same passion, when we are here, like second sorry, second column and first row. So second column, first row. So in this case, whatever the element we are containing, what is the one to whatever it is, so I will be setting everything to zero, I will be setting everything to zero this time. So same goes with here. If I'm finding zero here, I will set everything to zero, and I will set everything to zero, right? You can see, right, on the second column, or sorry, or second row and third column, we didn't find anything which is indicating as zero. So on the last, my bad, I think I missed that here. So you can see it over here that it won't be treating everything. So it would be same. So if we didn't find anything, any matching over it over here, like if we didn't find anything like which is just getting in, if anything we didn't find as a zero, so in that case it will be one. So but if we find anything like here, we can see, right, so entire column and entire row, right, would be zero. So this is the entire column, and this entire row will be zero because of this. So this particular row will be zero when we are using this, when we are referring this. So entire row and entire column will be zero. So similar goes with here. If we are finding zero here, then entire row and column will be zero, and this is what we are returning in the output, because we have finding zero here, right? If we are not finding here, then we will not able to set everything. So this is the simple expectation from the problem. Now let us think how we can solve this problem, right? So what we are doing, we are actually trying to find the rows and columns where we can match, where we can make it as a zero or not. So for example, if we are at here, right, I'm trying to find whether where does it found, right? It is found on the first column, right, and the zeroth row. So I have to make sure, okay, zeroth row should be marked as a zero, so that whenever I'm coming, I'm visiting that, then I would be marking everything as zero. So for example, if I'm finding here, then if anything is containing, then I can directly mark it as a zero, right? And same goes with here. I can directly mark entire column is at zero. But do you think, right, as and when we hit, right, for example, and when we as and when we see like zero is found it. For example, yeah, 0 and 1. This is my index of this. So if I'm hitting at 0 index, if I directly mark it, okay, if it is whatever the remaining index on the right side, whatever the remaining element from the left side on that on that row, and whatever the element containing on the on the entire row, so entire column, can I mark it as 0? No, because we never know. For example, if we just start from beginning here, we just change it to 0, right? Then if we are marking everything as 0, right, and if we mark everything as 0, so when we are going on a second case, right, so if we go here, then in that case our 1 is not 1, it is 0. So I will mark this and this is interchange. When I will go here, this is 0 because we are marking, for example, we found anything over here, then we are marking, and because of this 0, this particular column and row will change. So if we see here, right, I am maintaining the state 1, I won't able to, because I'm not keeping a track of that. This is the edge case you have to consider, though you have to do in place, in place, replacing the value of 1 to 0, but it's not that straight, right? You're not supposed to, when you find hero, you can mark it entirely row and column 0, but we can create a trick. For example, if I can mark this row and column, for example, if I just do the calculation, how many rows are there? So there are total 4 by 4, right? Means it's a matrix of 4 by 4, 4 columns and 4 rows. So if I'm able to, for example, when I found, it's found on the first column, right? When it found first column, so I would be marking as first column as 1 or 0, whatever you can consider. So first column is 1, so because we wanted to change it, right? So initially it is 0, so I wanted to change it to 1, so I can mark it as a 1. And then as and when we found, and the first column is marked as 0, another than what I can do, so we have already marked this, but I also need to mark this as well, in order to, because 0th column, first column is 0 and 0th row is also 0. So I need to keep a track of 0 row, column and column, in order to keep a track whether where I did found that element or not. In second way, let me take a smaller example, 1 0 1 1, right? So this will be 0 because we found 0 here, so I have to be converting 0 0. This will be 1 and this will be 0. So what I'm doing, this is my column, right, and this is my row. So whenever I'm finding 1 or 0, right, for example, my condition is 0. When we are finding 0, we have to mark entire column, entire row as 0. So I will keep a track of row 0 is 0 because we found 0 in the column 0 1. And when we are finding the column 1 is 0. So I will check, okay, 0 column is 0, 1 column is 0. So that's how we can able to mark it. Now let me try to give one more example. 1 1 0 1 1 1 0 1 1, right? So this is my column, right, and this is my row. So what I will do, right? I have found 0 where? In the last column. So what is the last column? It's a take a second column, and it's a column, row is sorry, row is 0. So what I will do, row is 0 and column is 2. So whenever I'm finding, right, whenever column 0 is, wherever column 0 is, row 0 is, I will mark this straight, and column 2 is, I will mark it as 0. Again, when I'm finding 0, column row is here, sorry, my 0 is here. What is the value of the, what is the row index? So row index is 0 1 2. So row is it equal to 2 and column will be 0. So I have to mark the column, entire column as 0 and entire row as 0. But if are we placing anything, we didn't do anything, so I will keep the matrix as it is. This is my answer. Now let's try to solve that real problem. So what I'm doing, I definitely need to keep a track of the row, and I will try to get the row as like this. Okay, then I definitely need to keep a track of column. Okay, so what is the size of my first column? Would be my size of that entire column. Now, in order to keep a track of where I found the first 0 or where I found the 0 or not, so I need to keep a track of that row and that column. So I will just create, because I need to keep a track of each and every index of that column, right? I am not supposed to find anything here and there, but whenever I am finding that, I will be marking that as a 1. So I will create matrix, sorry, matrix as, and I will just initialize it as a 0. Also, need to do one more, like, so what I did, I just initialize rows and columns to be 0, considering those whenever I'm finding it as 0, I will treat it as okay, we found. If not, then we'll just straight away go to the next. But how I can mark that? As in the first iteration, I will be pointing it out whether did we find the 0. If we find, then mark the entire column and entire row as a 0. So I will just mark that in the first go. We can see mark the row and columns. Okay, so how I can mark? I will simply start with the 0. I will go to the sorry, last row. Then again, I will start with one more one more loop where I will start from the column. I will go till the last column, and here what I will do, I will just try to check if right, because I wanted to check if matrix of I comma j, if it is 0, right, if it is 0, then what I'm gonna do that whatever the rows number is I will mark it as a 0, and the columns is j, I will also mark that as a, okay, so I have already initialized it as 1, so I will just mark it as a 1. And in the last, what I will do, I will again need to just replace the value. So for I will start again, iterate with one more loop. And I will just try to, if rows, the particular rows is equal to 1 or not, because that's what we are marking, or the columns which we are referring is equal to 1, is that 1, right? Is it 1? If it is 1, then the particular element which we are referring, we can straight away mark it as a, right. This control transaction will go unless until the entire loop is finished, and I think with this we will able to mark everything as a 0 whenever we find the rows or columns as a 0. Let me try to run that, whether the solution which I'm writing is getting accepted or not. Let me try to run this. Yeah, I think whatever the problem, whatever the sample test cases are there, it will get accepted. So if we try to submit it, it should get accepted. But right now, I know that my solution works perfectly fine. Let me come to the main important find. It's what is time complexity and what is space complexity. Okay. So here you can see like time complexity, because we are using couple of loops, right? This m and n. We never know, it's not square matrix, it's m by n. So there might be 3 column 4 rows, 4 column 3 rows, so it might be a different scenario each and every time, so we don't know where it is. So it's not n square, but it's m by n, so m into n. Its the time complexity is in every scenario m n into m. Okay, so this is my time complexity, but we are using different rows and columns to in order to process and store something. So that's extra space which we require. What is extra space we required? We are using two different vectors to store. First is for the row, and second is the for column. So I think on a higher level we can see that O of n plus m, this is my time and space complexity. Now we already got a solution for this, right? It's time to improvise this, right? It's time to think, can we improvise this? Okay, so uh, without a further ado, we have already understood how we can think for solving the problem. Now the main important aspect is that how we can build a solution which is optimal, because we can see we definitely able to get the solutions. Let me try to see whether we are getting any TLE or not over here. I think, yeah, we are able to submit this, because it is accepted that of n plus n into m is accepted, and space complexity is also accepted, because we anyway we have to move n into m, because that's not because we have to move each and every element. So of n into m is definitely time complexity expected. But can we improvise this space complexity, because we are using different data structure to store and process? Can we improvise this? Are we can we get rid of this? That's the important task. So what I'm gonna do, what I'm doing over here, whenever we are finding the particular rows, like so I'm just marking that rows or columns as a 0 or as a 1, so that I can, whenever we are going for the second iteration, I'm just making sure that I'm not using that again and again. So in this case, what I will do, I don't want that to use, right? I don't want it to use. So what I just want that whenever I'm finding that column, right? Whenever I'm finding that column, for example, it's a tricky, right? For example, if I start from the 0th index, and again I will start from the 0th index. So whenever I'm doing, I don't want to do the transaction of that as and when we find it, but we wanted to do it separately, so that we won't be missing up with the first column and first row, right? Though we are using the first row, but the column should be different, because if we start with the same column again and again, then we're not able to do the find, as I explain you over here, right? As you can see, like for example, if I'm finding 0 here, right? if I'm finding 0 here, and if I directly mark it, okay, mark it as a 0, mark it as 0, then whenever we are going for the second iteration, like, for example, row is 1, row is 0, it will work. But when we are going on the row 2, also row 1, we will try to find, okay, whether that particular row is, the column is 0. Yes, if it is 0, then I will try to mark everything as 0. So it won't work. So for this particular row and this particular column, I need to keep a track of something differently. In the first brute force approach, what we did, we just created separate rows and columns to just mark it when I'm finding anything, column, that particular column and row as 0. So I'm just marking that column and row as 0. But here, I don't want to use that, those extra variables, those extra data structure process. So what I will do, I will just keep a track of this column. So for example, I'm finding here this 0, this 0, this 0. So I will just mark those only, right? So for example, I'm at 0, right? And my column is here, my 0th column is here. So I will just try to mark this as a 0. For example, I'm at row, first row, I will try just mark to 0. I will try to mark this here, right? But whenever I'm trying to move from here to here, I won't be considering this, because I don't want to keep a track of this. I don't want to keep a track of this. How? Let me elaborate you now. So what I will do, I will just try to use no the particular column. Why? Because I wanted to get rid of rows and columns. So I need to keep a track of first row and first column, because if we didn't keep a track of that, then whenever we are doing transaction, like, as I said here, right? For example, if we are just replacing it by 0, so whatever the next element, we will not able to keep a track of that. So what I will do, I will just create a variable which is just giving me the column of that first row and first column, and then I will just try to move it from the next one. How? If I will be, explaining you roughly. So we have already solved a problem, and then the main agenda for this is that, so we'll just try to convert this column as a 0. And then when we are finding that particular element, right, when we are finding that particular column, so for example, this is my 0 column, right? So, for example, I will take example 1 0 1 1 1 1 1 1 0, right? So in this case, let me do it for the first 0 as well, because we want to keep a track of 0. Okay. So in this example, right, we know that we found 0 in the last row, right? We found the 0 in the last row. So when we are finding that 0, right? So when we are finding that 0, so we have to make sure that entire row would be 0 and entire column would be 0. So entire column would be 0 and entire row would be 0. But if we try to replace, then everything will be changing to 0, and we don't want to do that, right? We don't want to do that. So I will just mark it as a column as 0. And then we found that whenever we are finding that, we'll just try to update. Okay, are we finding, where we are finding, are we finding it over here, are we finding it over here, are we finding it over here? If we find, then we'll do it last, because we just wanted to keep a track of it here, track of all those variables. Wherever we are finding, we can always replace, like, because this is redundant. And secondly, for example, if we go here, we'll not mark that element, but we'll try to mark this and this, because these are the reference point for us. For example, if we find, okay, so for example, rows is 2 and column is, for example, sorry, rows is 0 and column is 2, I will mark it as a 0. And same goes with here, I will try to mark rows is 2 and column is 0 as a 0. So if any one of them is 0, right? If any one of them is 0, then I will straight away mark it as a 0, right? Because we have to solve, I will just try to update this. I don't want to use this. So what I will do, I will just try to use columns is equal to 0. And here itself, what I will do, I will just try to check, okay, whether we have found that column as a 0 or not. If matrix, we know that matrix is starting from 0, but if that column is 0, right, if that column is 0, then we are straight away marking that column as 1. Here I won't be starting at 1, because if I start at 1, then I will again gonna lose that. And similar goes it over here as well. If we are just maintaining that, and we are just allowing it to move from this element to that index, then we'll be not keeping a track of that. So whenever we are finding, like, for example, I start with over here, and if I find that particular element is 0, so we'll not mark rows and columns. So we'll try to find the parent element, right? The parent first row and first column, sorry, 0th column and 0th row. If it is if that particular column, for example, we are at the first index, first column, so j is equal to 1. So in that case, I won't be marking at particular element, but I will try to go for the first 0th element, and I will try to mark it as 0. So how I can do that? So matrix of, because we have to refer that, right? So first index, right? And what is the jth column? Because I wanted to mark it as a wherever row is, for example, it's zero index, so column of the zeroth index should be mark it as a zero. And similar goes with it. So zero and wherever I'm finding the column. So those two will be set, right? So if in other way, like in other way, what we are doing, right? So wherever we are finding that, right? Whenever we are finding it, so ultimately where if we find it over here, right? So let me take one more example, 101 111 011, right? So when we are finding it over here, so we are marking it as a zero, right? And also we are trying to mark it as a zero. So when we are finding zero, right, it will be easy for us to rotate left and right, and we can easily able to mark, because we are trying to find whether the first row and first column is zero or not, right? For example, where zero is here, for example, my zero is here. Okay, for my zero is here. So what I will do, I will try to go here and I will try to set it as zero, and I will try to go it and I will try to set. If anyone, right, for example, if anyone is here, right, if anyone is here, I will try to find whether this row is zero or not. If it is, then I will again simply replace it. Similarly, for example, we are at here, we are just trying to find whether it's zero or not. It's for example, just consider it's a zero. So I won't be changing it. I will be changing its parent, or we can say the first row and first column. So for example, what is the first row? First row is there, and what is the column? The zeroth column, zeroth column and zeroth row. So I will go here and I will change it to zero. I will go here and I will change it to zero. So whenever I come in, whether if is there anything, right, for example, column or row which is zero, so if it is zero, then I will straight away zero. And that's how it is. We don't need to use, two different variable to store it, right? Now, okay, so we are just marking that as matrix 0 and matrix j or 0. Now I will just try to go back reversely, because what we are doing, we are just marking it as a first column and first row as a zero, right? First row and first column as a zero. So in this case, I wouldn't be traveling reversely. So what I will do, I will just try to traverse reversely. Okay. So integer I would be starting from n minus 1. It will be going up to 0, and then here again, J, we have already discussed that if we didn't consider the first row, then it will give a different result. So we are keeping a separate track for the column, the first column. So it will be up to 1 and j minus minus. Again, what we are doing, we are just trying to use the first column and first row. So I will use the simply same thing over here. If, right, if matrix I of 0 is equal to 0, or, okay, so whenever we are finding that, right, whenever we are finding that, so what we are doing, so whatever the condition we have used early, right, so we are just reusing it over here. Sorry, yeah. And then if it is the finder, right, if it is our found, right, so matrix whatever the element we have set, like for example, we are at the 2 2, we found the that element as 0, so we are going 0 2 0, the first second column, sorry, second row and zeroth column, also the zeroth column and whatever the rows, the first column. So we are setting that to 0, and we are also checking the same. So if it is 0, then simply what I'm doing, I'm just replacing that as a 0. Okay. And in the last, right, because we have already considered the first column is a 0. If the column is, the particular column is 1, right, because we know that somewhere we have found that, right, somewhere we have found that the column value is 0 or the column value is 1 or not. So if, right, if that column is equal to 1, because let me check, yeah, we are setting it as a 1, right, we are setting it as 1, it is 0. So if it is 1, then simply what I will do, matrix of that column, right? What was the column? The column, right? The 0, wherever we found that. So it would also be 0. And I think we don't need a different. Let me just format this. This looks better. Yeah. So you can see what I'm doing. I'm just using the column to make sure that where we have found the element column as 1 is equal to 1 or not. So whenever we are finding that column is equal to 1, so we just try to go that element and we just try to set it as a 0. Let me try to submit this. Let me see where it's getting accepted or not. So what it is saying, yeah, I just use that. I didn't do the comparison. So I'm just trying to do the comparison. Now, what next? Yeah, I think this is looks okay. Let me submit it. I think this looks pretty good. It got accepted. Now coming to the last step, time complexity. So we are using couple of loops to the entire transaction. So time complexity would be O of m into m, because we are using m as a n as a row and m as a column. So would be there. But look at the space complexity. We are just using the constant. Are we using a different data structure to store and process? No. So space complexity would be O of n. So O of 1. I think with this, we'll conclude this video and we'll try to see in the next video. I will try to upload all those videos. If you think that the videos which I'm creating is adding any value to your life, just try to like the video and do consider subscribing. Thank you. Bye bye.